Is the mathematical concept that I have been using to teach you how to add and subtract radicals? What was I doing that you already knew so I was able to easily explain adding and subtracting radicals? Is that Joe? No. Jose? Yeah, I was using the idea of a coefficient and a variable, yeah? Gets me 8x, right? But 5x plus 3y I can't do, right? Right. So we're going to keep that motif going, except we're moving into multiplying now. So 5x times 3x is what? 15x squared. 5x times 3y is what? 15xy. 6x, 5x squared times 3x squared is what? 15x to the fourth. And lastly, 5x squared times 3y squared is what? X squared, y squared. Right? Why does all this work? Why is this like it is? It's just how we multiply, right? How did you know that how did you know everything highlighted was that answer? What did you do to get there? Multiplied what? Coefficients together and what else did you multiply together? The variables. Okay, so doesn't it stand to reason then that 5 root 2 times 3 root 3 would be what? 15 root 6. Now, all of you who are in my grade 10 class, you already know that's right. But you were willing to try that, yes? Okay. Now, what is it about this that made you willing to risk that it was 15 root 6? Why were you willing to say that? You personally. Because like a bunch of people said it was 15 root 6. Now don't say it's because you taught us this last year, Myers. Why? Menard. Fractions. Oh, I see. Like if you're, okay, I read you. Okay, good. Yep, bringing in previous knowledge. No problem there. Okay, anybody else? Preston? Root 2 and root 3 are exactly like the variables. But when it was x and y, we had to write x and y. Why do you think we're allowed to make this one 6? Okay, I agree with you there. So by that argument then, Preston, 5 cube root 2 times 3 root 3. What do you think that might be? Manu? Okay, so Manrup is going with 5 sixth root of 6. Why did you make that a 6th root? Because that should be a little 2, yeah? Okay, so decent guess. Anybody got something else to add there, Preston? Okay, you could turn it into a fraction. All right, so if I had 5 third root 2 times 3 root 3, you want to turn these into fractions. So this would be 5 2 to the 1/3, correct? Times 3 to the 1/2, correct? And then you would want to do 5 times 3, correct? Which is 15. And then what would you do with the 2 and the 3? How? Are they the same base? Are they the same base? No. So, can I do this? Why not? Because if you go to exponents, they are not the same base. Everybody cool? Now I'm going to show you a wrinkle to that in a minute. So, of course, the rule is x root A times y root B is x times y root A times B if the indices are the same. Indices is, of course, plural for index. Everybody understand? Everybody good? So just like in variables, if they're not the same, I got to leave them as xy. So in this situation, if I had the 5 cube root 3 times 3 root 3, that would be 15 cube root 3 root 3. Everybody okay? All right. Oh, shoot. That was a bad example. Make that 2. So that would be 15 cube root 3 root 2. Now, when I just wrote that, I wrote it down and realized I'd made a mistake because I'm just talking out of my butt right now, right? This isn't planned. I'm just throwing numbers down. There's a mistake I made there. Okay? Remember, and this is what I want to write up here. This is the wrinkle in this. We all understand why square root of 5 times the cube root of 6. We all understand why that can't work, right? Because if I go to exponents, that's 5 to the 1/2 times 6 to the 1/3. They're different bases. Cool, right? So as soon as you see those different indices with different radicands, you just say, no, I'm done, right? But as always, well, not as always, but as often, there is an exception to this rule. And that exception is what I just accidentally did down here. And I'll show you what I mean. Square root of 5 times the cube root of 5. Now you're going to look at that right there and say, I can't do it. Why? Because it's different indices, right? You're going to look at that right away and say, no, Mr. Myers, can't do it. But this is the wrinkle. You can do it. Why can you do this one specifically or this type specifically, Jose? Because they're going to end up with the same base, aren't they? This is 5 to the 1/2 times 5 to the 1/3. Now they're the same base, aren't they? Which is 5 to the 3/6 plus 2/6, right? Right? And I would get 5 to the 5/6. Yeah? Now, 5 to the 5/6. This you could do. Is everybody with me? Now, it will be ugly because the answer would be 6th root of 5 to the 5th. Yeah? Everybody cool? Cool? Okay. We're not going to have a lot of this because I don't need this happening. All right? I just wanted to show you that 99 times out of 100, this is the way you do it in math. Every so often, there's not. Right? So be careful with that index thing, yeah? But for the most part, you're not going to worry about that. So let's look at this one. All math rules still apply. So, what am I doing with -7 and 5? What? Multiplying them to get what? -35. What am I doing with 3 and 8? Multiplying them to get what? 24, right? And then what would I do with that? Simplify. 4 and 6. Bring out the 2. -70 root 6. Yeah? That's how I would do this. Because this is a one-step one, right? As always, you guys will look at this, say, oh, I can do that, no problem. And you'll jump right into doing it like I do it, which is cool. There's no problem with that until the numbers get uglier. So I submit to you, in my notes today, I'm going to be writing it a little bit longer to burn into your brains what is actually happening. Do you need to write it the way I write it? No, of course not. But think about the questions you ask me and think how often I say, it's exactly like the one you did before. Everybody with me? So, what is really happening here, I'm going to write it out, because if I write it out, I can't do it wrong. Negative 7 times 5, root 3 times 8. Then negative 35, root 24. Then negative 70, root 6. Is everybody cool? Now, could I have simplified this root 8 now, before I do anything? Would that have been okay? Yes, but it adds a wrinkle. You got to remember that there's a 2 coming out there, and this is going to be 10, isn't it? Because I could have done this as such. Negative 7 root 3 times 10 root 2. Then negative 7 times 10 and root 3 times 2. Negative 70 root 6. I am not trying to confuse you by showing you multiple methods. What I am trying to do is show you that if you see a different path to get there, you can take the different path to get there. All right? Do you ever get bonus points for imitating the way I do math? No. All right? So if you don't see something I do, chill. If you see another way, do it. Okay? So you're going to do B, go. I would recommend, again, in this practice spot, actually writing out what is happening. Can everybody do the easy ones? Everyone can do the easy ones? Or it's just number times a number? We're all good? I'm going to take that as a yes. All right. This one differs slightly. Why? Because it's got radicals and an exponent. Do all the exponent rules apply? Sure they do. So what is the base in C? It is negative root 6. And what does it mean to square it? I'm going to write it again. Now, if I was showing all my work, this would be negative 1 times negative 1, yes? And the root of 6 times 6, yes? Which gets me positive 1, root 36, which gets me 6. Right? Now, this right here, this is just this. Root of x squared equals x. You've seen that before. I am writing it out because in a lesson or two, this principle is going to become extraordinarily important. So that's why I'm writing it out here, to get it into your heads. 2 lessons from now, you can do that, right? But right now, I cannot stress this enough. You should be writing it out. What's this one then? 4 root 3 times 4 root 3. 4 times 4, root what? 3 times 3, which is 16 root 9. What's the root of 9? So what's the answer? 48. Is everybody cool? Does everybody understand? Does everybody see what's going on here? All right, everyone's okay? All right. So E looks different. What's different about E? There's addition and subtraction, right? So maybe you sit there and maybe you say to yourself, self, I have no idea what to do with that. What would Mr. Myers say? Mr. Myers would say, do what you know. You know that multiplication is happening right there, right? So you would do that multiplication. Or, what's the proper word for this? Distribution. You already know how to do it. But you people, some of you, not all of you, so don't start yelling at me that you don't do that. Some of you see a question and you freeze because it looks weird and it looks scary. But it isn't. Do what you know, and that will lead you to the next thing. You know that you have to multiply that, which is 5 times 3 root 8 times 2. Right? Then what's the next one? Plus 5 times 2 root 8 times 3. And then what's the next one? 5 times 1 root 8 times 5. Now I just fill it out, or I just simplify it. 15 root 16, 10 root 24, minus 5 root 40. Now, if you get to there, are you wrong? No, you're not wrong. Are you done? No, you're not done. Because there's more math that you can show me, right? This minimally meets my expectations. This is a 2 out of 4. Because you have shown to me you can multiply radicals. Now, of course, you would tidy this up. This is 60. This is 4 times 6, so that is plus 20, 20 root 6. And this is, of course, 4 times 10 minus 10 root 10. And I'd stop. Are we good? Are we good? Okay. What's happening with F? People always say FOIL, and that's cool. I don't like FOIL because it only works if it's binomial, right? But the concept works no matter how big the polynomials are, right? So if we're going to say FOIL, we'll say FOIL. I'm going to use 4 different colors to remind you of how to do it. What's that one? That's the F for first. What am I going to write? So we're going straight to it. That's fine. 72 root what? 10. Cool. Then the red one. What's that? No. Plus 48 root. Then the blue one. What's that? Minus 45 root 5. And then the green one. Minus 30. No. Root 10. Radicals go with radicals. Coefficients go with coefficients. Then what? Where can I simplify here? I can do 72 minus 30, can't I? To get 42 root 10. Yeah? What can I do with the red one? That's 4 and 5, yeah? So what's that? 96 root what? 5 minus 40. That should be blue. Minus 45 root 5. Now where can I simplify? What's 96 minus 45? Tick, 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 tick on the calculator. How much? Plus 51 root 5. Please notice, again, for the billionth time, it's exactly the same as what you already know. Right? I am not standing on your head, stomping on your ear, trying to cram math in there, because you already know everything we're doing, yes? What makes G weird? The squared is outside. And a bunch of you are going to go squared, squared. How many people was that your first impression or first impulse? Is that right? No. Why not? Preston? Because, yes, this is a base. And that whole base is squared. So it is really 5 root 3 minus 4 root 6. And then again. So let's do this thing. Do I need the colors or are we okay? The other class liked the colors. They made me do this whole question with the colors. But I don't care. Just keep going. All right. What's the first one? 25 root 9 minus 20 root 18 minus 20 root 18 plus 16 root 36. Can I do any simplifying now? Some of you will want to simplify these 18s, but I wouldn't yet. Why? Because I'd put them together first. So I only got to simplify once, yeah? 25 root 9 minus 40 root 18 plus 16 root 36. Now I simplify. What's square root of 9? What's here? What would you use? 9 and 2. So what's coming out? 30 times 3 times 40 is 60. And this? What's coming out? 6. So what's the answer? Any more simplification to do? What is it? What is it? 171 minus 120 root 2. Nothing new, right? What's different about H? Cube root, but is that really different? No. Now, there is something crazy going on in H that I will offer you a piece of advice for. There's 2 ways I would attack this. One is what most of you will probably do, and one is what I will suggest that you should do. Everybody cool? Most of you, I hope, recognize that is 2 cube root 54 minus 3 cube root 4, and then again. All you recognize that, right? And all of you would recognize that this first one is going to be 2 times 2 and 54 times 54, right? Well, 54 times 54 is a huge number. Nobody wants to break that down. So some of you will simplify now, yes? And there's nothing wrong with that. But I submit to you, I think it is easier. And again, what were the operative words there? I think that this is easier to say 4 cube root 54 times 54. And then simplify. Because if I simplify now, I got to bring stuff out. Maybe I screw up every time I bring it out. Understand? And then the next one will be minus 6 cube root, and I would leave it as 54 times 4. Minus 6 cube root, 54 times 4, and plus 9 cube root 16. Then, again, most of you are going to want to start simplifying under the radicals. But I submit, why simplify 4 things when they can go together? Right? So I would go 4 cube root 54 times 54 minus 12 cube root 54 times 4 plus 9 cube root 16. And now I will start simplifying. What's 54? Of course, that's 27 times 2 and 27 times 2, right? What's a cube root of 27? Cube root what? Nothing, because it all came out from under there, yeah? What's this one? Am I happy with that? Some of you will argue, some profs, teachers will argue, do them in descending order. I don't care. The only reason I show you that is because if I stole a textbook page and put it in your book and put the answers there, they may change the order up. Okay? Is everybody good? Nothing new. 42, 43 is your work. Yes. Good question. So here's what I like to do, Priya, when I'm trying to think of that. I remember there's certain things we never write, yeah? This is technically 1 root 5, right? And this is technically 2 root 1. So 1 times 2 is 2. 5 times 1 is 5. So this would become 2 root 5. Okay? That's what's really happening. Now the shortcut is what you asked. Does 2 go outside or inside? Well, now that you know what's really happening, you now know that the 2 would go outside. Right? Any other questions? Okay. Now, ladies and gentlemen, I'm not stupid. I know that some of you are honestly sitting there and saying, okay, I know all this, right? Maybe I haven't practiced it. Maybe it's longer than I'm used to practicing. But why are we already in the 3rd week of school still not doing new stuff? The simple fact of the matter is there's a big jump coming. And this stuff needs to be not able to do that fast, but needs to be locked in your brain. Because what's coming requires a very thorough understanding of why all this works. Everybody cool? It's not because I think you're unintelligent. It's not because I think you're babies and need to have it repeated 17 times to you. It's not any of that. Okay? All right.